All right, folks. Looks like we're right at 11, so we'll go ahead and get started. Welcome to Graphics Programming with SDL3. My name is Mike, and thanks so much for choosing this session. And thanks again, CppNorth, for inviting me to come speak. It's a real honor, and it's been a wonderful conference. And again, sad it's the last day here, but well, we'll just make the most of this day as we can here. So I'm going to be talking about graphics programming. This is for a sort of beginner to, well, any level audience here. If you are an expert already in SDL, you might know a lot of this stuff. I mean, I'm going to be running through some examples to get us basically started and make, or rather approach graphics programming for anybody. I think this is a great library to start with. And feel free, though, if you are an expert or want to ask other questions about SDL, to raise your hand at any point. We'll keep this sort of a interactive talk, as I like to do. All right, so anyway, there's a talk abstract here. I am currently a teacher, teaching faculty, and teach computer graphics in various domains, mostly in game programming, and of course do a lot of C++ stuff. I am going to point you to YouTube if you want to see other C++ stuff that I'm working on. But specifically why I'm mentioning this is I've started putting a lot of effort into SDL-related tutorials. So the stuff I'm going to show you today is sort of the fast, getting started with SDL and a few different things here. But if you want a little bit of a slower breakdown of how to do something or set up SDL, which we'll also talk about. I have videos there where I try to purposely make mistakes and show you how to fix them and ultimately get set up. So feel free to Google my name in SDL and you'll find something hopefully useful. But where I want to start here actually is a little question here. How many folks got started or interested in programming because of games? Okay. Handful of folks here. I mean, that's how I got started, and that's how I've kind of stubbornly continued programming in this game and graphics sort of industry. I've worked at a variety of other different things here, but that's what's always captured my attention. So you can see if you know some of these games down here. But I do want to talk for a moment about the business side of video games, and I'll talk about how that relates to SDL and the problem that it solves. Just again, as a brief aside here, I mean, the video game industry is very large. Video game graphics, entertainment. These days, the budgets of some of the big video games, what we'd call AAA titles, is rivaling that of Hollywood movies, which is quite incredible. As somebody who loves the industry, seeing it continue to grow is absolutely wonderful, for someone like myself. And the last few years have been, tougher years on the industry. Things are a little bit cyclic, but again, it's still projected to keep growing. People are learning game programming. People are doing cool things. We're seeing more VR stuff, mobile. There's lots of different ways to engage in this industry. And people who learn this stuff will often take that skills into medical industry, medical visualization, data visualization, all these other things. So it's really kind of fun to see this industry blossom, or at least over the span of my career here. But one of the things about the industry that I think is interesting, if you are a developer, whether large or small, and why I bring up this figure of it growing is, well, how do you ultimately, when you make a game, get that game to your audience? And this is a screenshot of the Unity 3D game engine. There's Unreal, there's custom engines, but many of them have this sort of screen that's interesting, and you'll see if I draw your attention just to the sort of left side where it says platform, and I can just export my game out to Windows, Mac, Linux, or do a build for Android or web, or one of the game consoles or whatever other platform. And that's actually a really important step in getting your game to audience, right? By having multiple platforms supported, right? If I only own a PlayStation, well, I can't buy your game if it isn't for PlayStation. So this step here of having a cross-platform sort of way to develop games is very important. And a lot of the work that these game engines and tools do is make that step sort of easy, right? Having this abstraction layer for how we do things on Windows versus PlayStation versus Linux or whatever platform you have. So short of this and localization, translating your game to different language, these are two really important steps, I think, for, again, just getting your game into your audience's hand, or whatever application you're building, really. So if we want to do this, how do we support multiple platforms? Well, I actually looked at some SDL code, which we'll get into, but maybe you could write a function that looks something like this. I've just zoomed in on a part here, and if you can't read it, where you basically have a pound if statement that says if this platform is Win32 or Windows or Mac, do this version of the function or return this value for some feature that's supported. And you basically have a bunch of these if, else-ifs, maybe at a per function level. And that can be a way to sort of support multiple platforms. Now, that can make your code a little bit ugly, let's say. So we can improve this a little bit. This is a trick I actually learned from one of Kate Gregory's book, Beautiful Code. Maybe we can abstract things a little bit better and just have a include file that does all the stuff for the Windows specific things. But if we're on Linux, then we'll do a build with all the Linux specific things. So we can leverage our build system here and then not at the function granularity have all these if and else if sort of branches in our code. Okay, so a little bit better here. So writing all this code ourselves, for all these different platforms or thinking about this abstraction level is it's quite a big task if you're already building a game. That was your ultimate goal here. So, if only there was a well-tested, cross-platform, industry standard almost library that did this for us. That's the exciting news. That's what this talk is about here. These libraries that exist to basically take care of this abstraction layer for things that are platform specific, like how do I pop open a window on my Linux machine versus a Mac versus an Android, etc. So that's what today's talk is about. Today's goal to show you SDL, specifically version 3, some examples so that you can go ahead and get started if you want to build an application that runs across multiple platforms with the same code. They've already done the abstraction layer for you, so you can write the same program and effectively run it everywhere. That's sort of the promise here. Okay, so SDL, what is it? It's the Simple Directmedia Layer. And again, it's a multi-platform library typically used for games, but lots of other media applications use this, and it's written in the C programming language. A portable subset of the C language, I should say, that is completely compatible with C++ as well. So the SDL library is, as far as what it contains, it does things like windowing, if you want to open a window, handles audio, has sort of a layer for that, input, keyboard, mouse, if you put a joystick to your computer, a gamepad, whatever sort of devices you have, it adds support for that. SDL version 3 also has some cool stuff, like if you have a webcam, takes care of that as well. So whether you're on an Android device or your desktop, you can interface with those devices. So there's other stuff too, like stylus and so on. SDL supports many platforms. I've listed a bunch here. The main desktop platforms, mobile platforms, consoles, web, and even stuff like PlayStation 2 and so on. You can find branches where people just have that set up, which is really awesome. And the library can be statically or dynamically linked, depending on your preference or how you want to deliver your software. So it's quite flexible here. In SDL, I have some pictures of some games here. Maybe you're familiar with or not, but the point is it is relatively industry standard from large games to small ones. So again, whether you're an indie developer or a hobbyist just learning this stuff, or one of the big game studios or companies, everybody's likely used or knows about SDL in this domain. And SDL itself was born about 27 years old. So it's a library that's gone through 3 generations, SDL 1, 2, and now 3. And it was born exactly out of this problem of somebody said, hey, I want a window that I can just pop open and run this Macintosh emulator for games here on a Mac and Windows. So Sam Lantinga, who's currently at Valve, is the original author, still working on the project. Wrote that initial windowing code here so that you wouldn't have to learn the Windows API and whatever the Mac windowing API at the time was. Ryan Gordon's the other person to know about, and I just want to give credit to them, who does a lot of the contributions as well. And he got his start in porting games, so again, thus the need for this. Okay, some other things about SDL, as I mentioned, it is open source, so you can see the implementation. We could dive into the code and see exactly how it works. It's got an open license as well, so it's free and easy to use. And again, it is written in C, which is really, really nice because then we can use it again without any problem from C++. Or if you want to use other languages, you're welcome to do that. There's bindings to SDL. So your effort learning SDL today is not wasted time. You can use those skills and choose whatever other language you want or alongside your C++. Okay, so again, industry proven, 27 plus years, and it's been a relatively stable API as well. Once they sort of lock in what the function calls are and how this is going to work, it is stable. And again, that's an important thing. That's a reason that I enjoy, using C++ is largely the code I write I can reuse and recompile years and years and years down the road. There aren't many breaking changes. So SDL tries to preserve that same sort of mantra, so you can recompile your games that are using SDL from 20 years ago with the same version here. So get a nice feature of SDL and its development. Okay, so where does SDL fit into all of this? SDL is this sort of windowing, input, audio. It's got all these different libraries or functionalities for cross-platform development, but it's not a full game engine or graphics toolkit, so to speak. It does have some abstraction layers and abstractions that we're going to look at. You could build a full game using SDL or full graphics application. Many people do that. They build visualization tools. But it doesn't, for instance, handle loading arbitrary 3D data or handle all the file formats. It'll just give you sort of a basic subset. You'll still have to write your algorithm for doing some sort of spatial partitioning or the things that game engines maybe handle for you. So it sort of sits in this layer where, again, it's handling the windowing stuff, whether that be Wayland, Windows, and so on. It can talk to graphics APIs, which we'll talk about at the end, like Vulkan, Metal, Direct3D, the various versions of it. But that's sort of where it sits in this diagram. Okay, it's the thing that has the abstraction to all the system-level calls that your operating system uses or the C library to generate a window. All right, so again, just on the abstraction layers, I've listed out a few of them. As of SDL3, they've added a bunch of other nice stuff like handling HDMI displays, different types of inputs, pen events, and so on. There's even threads in SDL, so if you want a cross-platform way to work with threads, I mean, we have this in C++, but that's available. File I/O as well has been abstracted upon, and much, much more. So there's a lot of little goodies here, even if you're not specifically wanting to take a look at the graphics portion, which we'll focus on. And SDL is not the first library to think about or try to challenge or handle this challenge of multi-platform or cross-platform support. SFML is another great library that is written in C++. It happens to be, I think they've just upgraded to C++ 20, so you can find some goodies there. If you just want to look at code and how some of these abstraction layers are built, those are good sources, but there's a bunch or a multitude of these frameworks which you might have also used. Qt, WXWidgets, GTK, some of those are typically more focused on the widget side of things, but they have ways to interface with hardware and so on. So feel free to take a look at those if those are a better fit for you. All right, so that's with the introduction to SDL. We should probably get set up, and then we'll look at some code, run some examples, and then all of this will be posted shortly after the talk as well with the slides and GitHub examples. All right, so how do we get set up with SDL? Well, again, as I mentioned, I have a bunch of support on that, but it is a relatively simple build. You can just download from the GitHub and use CMake to do a build and get a make file or whatever you prefer and build it as a static or dynamic library. And again, it's generally a easy tool to use here. So let's look at SDL a little bit here. Some examples. I'll show you a first SDL program in C++, and we'll flip through some code and feel free to ask questions if you have any. All right, so the first SDL program. This is really it. I mean, it fits on a slide. It's 6 lines of code here if you're counting the text that's showing up in white text here. And it's as simple as that. This program will run on 20, 30 plus operating systems or systems, and I don't have to change a thing, which I think is really brilliant. As somebody who has written some of these abstractions and native platforms, you know, just getting a window sometimes is hundreds of lines of code on different platforms. So this is really cool and something that you know, is exciting to me. So let's actually show it. Let's actually run it. I'll flip between here just so we can see how easy it is. Here's a little bit of big text here, but we initialize SDL. And at line 11, where I'm drawing your attention to, you initialize the parts of SDL that you need. So you don't pay for anything that you're not using. So I'm only using video and graphics today, but again, there is audio, there is networking, and so on that you can add into the SDL libraries, but I don't pay for it. But I do need to explicitly set it up. So that's the first step here. Then I'm going to create a window here. Most of the structures, most everything you're going to see that's SDL is SDL underscore, because it's a C-based library. That's the sort of namespace. And then we can create a window here. And then what this program is going to do, if I scroll us down just a little bit here, it's going to delay for 3 seconds here, 3,000 milliseconds. And then I will destroy the window and turn off SDL. I will shut it down here, all right? So let's compile and build this. I'll zoom in on this step in a moment here. There's our window, and shut up in the top left corner, 3, 2, 1, it's gone. But hooray, it worked. Simple as that. So yeah, thank you. That's the hardest part, honestly. It compiled and built. It's a success. We can pretty much leave now. So. All right, so what do? We should dive in a little bit more here, but so I'm demonstrating this on Linux, and again, there's a multitude of ways to build this depending on how your paths are set up and so on, but it can really be just as simple as this first line here: compile your C++ as normal, and then link in the SDL3 library, which you've built or maybe installed from a package manager or a brew or you know, VC package or any of those tools generally just kind of works, which is nice because, again, it's a library that's been around for a long time and has a large community. I tend to use a pkg config, package config here, and again, just include the libraries or C flags, and again, you can choose CMake or whatever, CMake, Conan, you know, VCK package, and so on, all also work. So simple as that here. If you need help with compiling stuff, again, more resources on understanding that. But the other thing that I wanted to show that's kind of interesting and is part of the documentation is there's more than one way to create an SDL3 app. And they've really leaned into giving you this other style here. What you'll notice is a little bit longer than the example that I showed here, but it consists of 4 functions here. There's one from lines 20 to 28, 31 to 38 here, 41 to 61, and the quit 65 to 66. So what you will notice, this is the whole program here. I grabbed it straight from the docs. This is there is no main function here. So SDL allows you to build this without a main function, have sort of this callback API. So if you've done other programming in different languages or sometimes with other window-based languages or processing, P5.js come to mind, you have sort of this callback API. And this might fit better if you're doing web development or targeting web or maybe mobile devices where you can't have sort of the main loop here, but rather just callbacks into every time the application gets a cycle to iterate, you can do that. So this is kind of a nice fit. This was part of SDL2. You could do this, but they started putting more effort in this style because, again, web is going to be a big platform, I think, for games and graphics. So just wanted to show that this is another style that you can do as well. You can take all the examples that we're doing today and just stuff in the app iterate function where your main program loop is. Okay. So with that in mind here, another focus of the SDL library, and again, an advantage of its portability, is that you can compile to WebAssembly. So we can take that same Hello World program and execute it, but use the Mscripten toolchain. I recorded a whole long video to show you how to download and set that up, but I'll just draw your attention to the bottom part first here. That's using the Mscripten compiler. How many folks are familiar or have used Mscripten? Okay, good number, 7, 8 folks. So it literally is a replacement for the C or C++ toolchain to compile to web. Some libraries and portions, I should say, of your C programs. But it was just as simple as just using and turning on this flag for SDL3 once you download Mscripten, and then building and getting a hello HTML page. And the really cool thing, as we'll go through some examples in learning SDL, is that much of the documentation now, since they've leaned a little bit further into this, is now on the web. So I can just click on examples here, and I have all these SDL3 examples. I'm going to choose one of the fun ones here, the camera. Well, they're more fun but more risky to run, but hey, it's just on the web. Okay, let's allow the camera here. And you'll see I have my camera here, so you can see me or part of me here. And this is, again, all in SDL. How did they do that? Well, I'll just scroll down to the source code, and you can see the C code here. And if I scroll down here, I mean, this can't be more than 100 lines by the time you take away the spaces, maybe 50 lines here. So that's all it takes. Set up a camera, and you have things up and running here. So some of the other, simple examples that we'll get into, like just displaying a screen here. Again, you have the source code in C that you can compile to Mscripten. So that's a really exciting thing for me to see this, the ease at which that is available. Okay, so let's continue forward and talk a little bit about the basics of SDL, the application structure. Okay, so again, here's our minimal SDL application that pops open a window. Great, and we can do that on 20, 30 plus platforms, including the web, as we've seen here. So let's move along here. Now, I will do a little apology. Most of my slides are not going to have checks for null, checks for errors, things that we've talked about at this conference. But there is a error handling library here for SDL. There's SDL get error, there's logging facilities to report back. Most functions in SDL3 now, so if you're coming from 2, also they've kind of improved the API a little bit to just return Boolean values from each of the functions, so it's a little bit more consistent. So did this work, did this not work, and you can catch that error. So a little bit easier to trap here. Okay, so back to our minimal application. I mean, it's not very exciting if our program just pops up and goes away. We probably want to keep it around for a while, right? Okay, so we need some sort of infinite loop, right? Graphics applications are sort of run forever. So let's talk about this guy here, the event loop. And specifically, we're going to talk about this, our friend. We're using Union since it's a C-based library. Again, C++, maybe we'd use some sort of tagged Union, a variant or something, but Union will work just fine. But let's get something that actually stays and runs for a while. So here's the additional changes highlighted in orange here. We are going to start processing events. What's an event? Well, that can be anything like a keyboard press, a mouse click, these types of things, windowing things that you want to intercept and see what happens of interest. You could create your own events if you want to pass into this system as well, by just adding or modifying this SDL event structure. But again, basically this loop here, this is my main application loop that's going to run forever. I'm going to just grab events, figure out what the type is, and then do something. Okay, so let's actually run the program so we can see it running, and you'll know how to do that. Let me show you how I'm compiling it here. This will be sample 2. And there's the application. It is running, and if I press some keys, I will see some key codes. Okay, so it's at least doing something. It's staying alive, and it's up and running here. Okay, so what happened there? What was interesting? Well, again, this infinite loop that's polling for events, and this is happening consistently, but not forever. So it's not blocking, right? We want our graphics application to eventually run and show something. But we, again, handle any of the events that we're trying to handle here, we want to handle and then maybe break out of our loop or log something that happened. Internally, SDL has a first in, first out queue, a FIFO queue, where it is pumping in these events. And these events, let's say again I move my mouse, I hit the keys, again we'll get queued up, and then you handle or process these. Those events will expire or time out. So again, every roughly 1 millisecond, if you look at the code, so if I just spam my key, for instance, and it flags my application, they might expire. But again, that's the internal loop here. Okay. All right, now again, what types of things can SDL handle? Well, here's the large list. I'm actually going to go into it here so we can see it here of SDL event here. So what types of things are events? And again, pointing your attention to them being a union here. So basically anything that's an SDL event will be like, well, what did we do here? Keyboard event, if we want to see how keys are handled. Maybe we do something with the mouse, etc. And they all sort of have this form where everything that's part of this has a type here as the first field. And then, of course, being a union, if we want to treat this as if we get the type as a key, then we can handle a keyboard event. And on the same page, and this is something that I see folks, if you're just new to the API struggling with, if I search for keyboard event, it'll bring us down to the bottom of the screen here where we have this nice big table here telling us the relationship between the event types. And we have stuff like, was a key pressed down or was a key pressed up? Okay, so that means it's event.keyEvent. And I can go into the SDL keyboard event struct here, and then this is the thing that I'm interested in. And most likely I'm interested in, if I have a keyboard event, seeing what key was pressed. Okay, now I've got two sets of things because again, SDL is a pretty thorough API. I mean, I can handle virtual key presses or physical key presses. And if I look at my keyboard, it looks like the physical H key is right here, so what's the difference? Well, this is for the actual keyboard layout, but the virtual key is probably the one that we want to use that just says, okay, the letter H or M or whatever was actually pressed. Okay, so if you change your layout or something in your settings, that's the one you want to handle. And there's other things like seeing if the key was pressed or if the key is on repeat and so on. So anyways, that's just a little explanation of how to explore this API. All right, makes sense for folks? All right. Okay. All right, so we went through that, kind of understand here. So that's kind of the basics. I mean, if we can do that much, pop open a window, handle key presses, mice input, and a lot of other stuff, that probably gets us a lot of the way of building some application that's not just some terminal-based thing. But of course, we want to render stuff. Okay, so let's look a little bit at the video API here. And SDL provides us with this baseline 2D graphics API. Okay, so what it gives us is this other type here called a renderer. So we can attach this to our window with some flags on it. That'll again let us do some hardware accelerated 2D rendering. Now there is also a software renderer that they've kept alive as well. So if you don't have a graphics card, or again, if you're working on some device without hardware acceleration, you can set a flag to basically have that available. But we probably want to do GPU accelerated stuff just to do something a little bit more interesting. Okay, so what do we need here? We'll go through some of the parts here, but basically I need to create a renderer, attach it to my window, so it'll be refreshing there, and then I've got these 3 steps down here, where every time I'm drawing in my loop, I want to clear the window, maybe set a new draw color, set some state, and then present that updated state, so SDL render present, my renderer object, and again it'll refresh and I'll be able to display something. Okay, so let's go ahead and getting into exciting SDL stuff. 3, we now have a little red window here. So I suppose I chose red here for my color here, but it's presenting this every frame as fast as it can to us again and again and again, clearing the screen in red and showing it. So pretty cool. And again, this is the type of stuff that well, I can show in a slide here. 40 lines of code. I have hardware accelerated rendering. Now, we haven't done anything interesting yet. We'll probably want to display something, so we'll proceed forward there. And of course, we can combine this with, something, here, let's get a little bit more exciting. The stuff that we learned before, our event loop, and change some state here. So in this particular example, if I draw your attention towards the middle, if I press the R key, the screen will turn red. Anything else, it'll go yellow. All right, so let's just go ahead and run that. So we can see something a little bit more interactive. Red, yellow. So, all right, there we are. Oh, all right, great, okay. Now, I do want to do a little bit of structuring at this point because I am sort of jamming everything into my main function, which is fine for these sandbox examples. In fact, anytime you're learning something, don't worry, just be messy, just get it working, and then we could add some structure here. So how would I do this here? So well, maybe it's just easiest if I show you the code briefly here. Let's do this here. This will be sample number 5 here. But basically, I just want to put everything into some sort of structure here, right? Again, I don't want everything in main. I want to try to avoid having global state. We'll talk a little bit about resource management here. But now I've got my window object, my render are all part of this singular struct for my application. Okay, and then I can have some initialization and cleanup, and now my main loop is where I'm going to jam everything into. This makes my code very simple in the main. Right, we could probably even simplify this more if we wanted to. But it also makes it potentially more testable. I can unit test things. And, well, if I think about what we talked about earlier with an event loop, having events pass one by one, I can really make this a test-driven system by controlling what events are pumped into my main loop and so on. So anyways, just a little tiny architecture thing, more for an audience that's maybe getting completely started in game dev. All right, great. Okay, so we've got a little bit of a structure, and now we want to start adding some more graphics stuff. So what are our graphics abstractions in SDL? Well, I got to give you a few things on terminology here if you're just getting started. Okay, foundational definitions here. Rendering itself, even just a 2D sense, is a enormous topic, and in 3D it grows even more here. But again, there are a few common things to talk about. So in SDL, we can render what are called raster graphics, so pixel-based. I have some image here that I want to display on the screen here, but it's made of discrete pixels, okay, that some artist made, and I can actually display here. That's one way to present graphics or art or a game to our audience. And if I want to animate them, it's kind of like making a flip book in the sense that I can change that image or what part of a particular the pixels that I'm showing here frame by frame. And again, there's a few different ways to do this. We can literally blit, which is a older school word, let's say for copy or mem copy new pixels to the actual renderer, or we probably want to do the hardware accelerated thing, which was the renderer present. So that's what we're going to get into. But again, this is how you can make the sort of start of a game here. Now, in order to make this a little bit smoother, let's say here, typically what we do is we take or prepare the pixels that we want to draw, and we put them into a back buffer, we'll call it. So a memory that's reserved either in CPU or GPU if we're doing hardware accelerated, and then flip the back buffer and copy that data into the front buffer once we're done saying, we want to present all these graphics. And that ability to be able to sort of flip the page here generally makes our animations a little bit smoother. Okay, SDL is going to help us do this, and this is effectively what's happening when we're doing the SDL render present. We're saying, hey, everything that we prepared, once it's ready, okay, present those graphics. Okay, and you can do all sorts of fancy stuff, again, in graphics, like double or triple buffer things, but for now, just think of it like a page flip when the artist is done coloring in the page. All right. Now, SDL also provides us an API for just drawing vector graphics. If you just want to draw just straight lines, boxes, no circles, you have to break out your trig to do that, or other methods. But you can just do SDL render line and these sorts of things here. Okay, and you can think about vector graphics either in the terms of the graphics, or things like fonts have different advantages in how the graphics scale or don't scale. But again, that is just another option here. Okay. All right. And as mentioned, one of our things that we can do here is literally just paste pixels into our window. But again, we want to take advantage of our hardware acceleration if we have a GPU available. So what we're going to do here is move some of our, or utilize rather, our GPU's memory, the video RAM, to copy our pixels onto the GPU and present them. Because again, that'll be faster, they'll already be in GPU memory. That's what our GPUs are really good at. Okay. The other thing, just to make things, again, just to give you definitions here, textures are typically what we're going to be working with in SDL, and these are the pixel data that exists on our GPU that we're displaying. Everything behind the scenes in SDL and the presented API is basically just a quad or a square or rectangle, depending on how you're scaling it, at the end of the day. But we're just pasting on top of it the pixels that we're interested in. Okay. All right, so this is where we're heading for our next step in the SDL API. We're going to take advantage of our CPU by taking some pixels stored in an image. In SDL, we call that a surface, just a general thing that holds pixels and the dimensions of the pixels that we're taking in. And we're going to upload those pixels by creating a texture onto the GPU. And again, then our pixels or that we want to display on the GPU are going to be readily available for us. Okay, so let's look at that video API here. Again, three important parts of it. A window, which we've already talked about. We created that in basically two functions. A surface, which holds pixels from our CPU, and textures. That's the pixel data stored on the GPU. Okay, sometimes called texels as well, but don't worry about that. Okay, SDL surface. Again, SDL will provide us an easy way to load bitmap images, which is a common format, again, in most operating systems, for loading a file of pixels stored, created by an artist onto a surface structure. You can create empty surfaces as well if you want to do procedural graphics or something algorithmic. Again, the goal of a surface is just to hold individual pixel data. All right, here's what the actual structure looks like. Again, the SDL documentation has all of the structs documented as well online or offline. You can download the documentation. And again, the main fields, usually the width and the height, and then the pixel data are the things you care about. You have control, again, with SDL of all the different types of formats, how you want to store the data, meaning do you need red, green, and blue colors, or just one channel of colors, and how many bits. All of that is, again, configurable from SDL. Okay, so on the hardware accelerated part here, again, it's really useful to just be able to quickly copy some pixels into our window, but again, that's going to be a little bit slow if we're not doing it through the GPU, so we need to create a texture. Okay, so we have a SDL texture, and we create textures. We can again create an empty one if we want and populate it ourselves, but we're probably most interested in SDL create texture from a surface, which again is just taking any surface that we have and allocating some video memory on the GPU there. Okay, and then we need to render things which we have seen before. So I'll go ahead and move us along here. And the new function that we are interested in, I'll just highlight the middle one here, is this SDL render texture. So we already know about clearing the window. That's how we got the red and yellow background. And we know about SDL render present, which says, okay, everything that we've called, every function call SDL underscore render texture previously, present it as soon as you can. As soon as that back buffer is filled with pixel information, present it to us. And one last little piece that's going to be helpful for us is this SDL rectangle structure. There's one for integers or floats, depending on the precision. But this is going to be how you decide, okay, I have this pixel information, where am I rendering it to, right? As I mentioned, everything is a quad or some sort of rectangular shape. So we use rectangles to figure out what part of the texture do I want to draw and where do I actually want to draw that texture. Okay, so I'll show the example here. Here we have a texture. So let's actually run the example here. And then I'll again show you the points of interest. I think this is number 6. Yep. We have a texture. Here's Mario with a yellow background here. But here are our pixels created from a surface, loaded up from a file called test.bmp, and hardware accelerated rendering over and over and over and over again here. Okay, so let's see what was new in our code here. Let's open example 6 here. So we have our application, our texture, our surface, and what was new, we created this surface here, loaded the bitmap, and then created a texture from that surface. And then how did we position it? Okay, I did a little bit of cleanup here. We got to go to our main loop. We had this guy here, this rectangle here that says, okay, I want to draw in the top left corner, position 0, 0. That's why Mario was in the top left. And the size here, 64 pixels by 64 pixels. Okay, those are our units. And if I scroll down a little bit here, we will see SDL render texture. Which render we created, the texture. There is a source parameter here, which is just null, which means draw everything that's in that texture. And then here's our destination. It says draw all of our pixels into that rectangle. So even if it's larger, it'll scale it down automatically for us. So we don't have to worry about that, but place everything in that rectangle. Okay? All right, so we can start doing some neat stuff now that we have textures here. We can actually start to animate it. Because again, we can select which actual parts of the texture that we want to display. So now, instead of just having this rectangle here that says, okay, draw Mario in the top left corner at this size, I want to take a larger image, but I just want to select as a source maybe the first pixels here, this first frame here. And if I move forward in my source rectangle and say, well, actually, I want to move 64 units forward in this image and select these next pixels here. And again, and again, and again, and again. Okay, and then we can start to have some animation here. So I'll run this little example here. Let's look at, it'll be 07 animated here. If you're following along in the GitHub repository, oops, 07 animated. All right, and then we get our little character. I just grabbed this one here, but but it's moving, and all of a sudden this is pretty exciting because if you have stuff that's animating, and then if you want to reposition this rectangle somewhere, that's pretty much it. That's pretty much a game at this point. If you start adding some things and some abstractions, I mean, okay, this isn't a game itself, but a component of it we can start abstracting around here. But that's pretty exciting to me. I mean, this is like 60 lines of code here that we have that SDL gives us, and it's going to run on 20 or 30 platforms, and we're going to take over the world with no. Again, not too many lines of code, and I think it's pretty understandable, pretty simple API to get things working. I'm using my GPU here, which is awesome. Okay, so a few things though. As you start to say, wow, we got this cool animated texture, let's start abstracting on top of it. Well, one thing to keep in mind is where are we allocating these resources? So one of my favorite features, perhaps maybe the best feature, say, of C++ is RAII. At least I like to make that argument of, one reason I love language, this idea that we have deterministic creation and destruction. But keep in mind when we're creating textures that are on GPU, for instance, or surfaces that are on CPU memory, they're kind of getting allocated in different spots here. And there's a lot of opportunity for reuse. So typically, this is something if I'm creating, let's say, a texture struct because I don't want to memorize these functions and I want to come up with my own abstraction, typically we have some sort of managing class, like a resource manager, where we have these textures. And then we just look them up maybe by the texture name or some sort of ID, because we can actually reuse it. It's the same video memory, so if I want to draw 50 copies of Mario, I can just refer to the same texture, and the GPU is really good at copying that 50 times for us. So we want to be a little bit careful with aggressively creating and then immediately destroying things if there's potential for reuse. So, smart pointer, maybe there's an application for this, or just having a sort of manager class that says, wait, actually, maybe don't delete the texture again until I explicitly say. So just something to think about, taking these examples and abstracting on them further. Okay, so there's plenty more to look at. And again, this is what YouTube's great for. Blending modes, okay, how do I make the background transparent with color keying, manipulating the pixels, scrolling the textures. Again, if you start adding up a few of these things, you have something that's looking pretty close to a game. And we haven't even gotten to the sound input, other camera, networking stuff. That's all part of SDL. But it's all there in one library here, so you can start building this up. But I do want to look at a few other things here. So there is a new 3D graphics library that's part of SDL as well. So let's talk about that, because we've done things in 2D, we've sort of lived in 2D land here. So what's the promise here? Well, we can do sort of the typical thing, and this is, what I would teach in a university course of saying, okay, we're going to use SDL as the windowing library. We have that, and then I'm going to teach a specific graphics API like Direct3D, Vulkan, OpenGL, and then SDL basically just serves as, it's got some helper functions that says, okay, I want to talk to the Vulkan library or OpenGL, but then if anything else I want to do graphics, SDL is basically just serving as a window that I can render into, okay? And then I'll do the rest of the graphics stuff in the graphics API, which is, again, totally fine. But the sort of interesting thing that happened with SDL3 is they said, well, a lot of these graphics APIs, Vulkan, Metal, Direct3D, is anybody writing code in these days? Okay, well, a few folks, yeah. Or experimenting with them, or going through some tutorials. What I'll say about them is, again, they're wonderful, but again, if you write Metal code, again, that's code for Apple's platforms, which again is going to be probably great, super optimized for those platforms. There's use case, but again, if you want the sort of SDL advantage of write once, run everywhere, then you don't have to learn the specific Vulkan, Metal, Direct3D 12 code necessarily. You again just write using this new SDL GPU API, and that'll allow you to use Metal as a backend, or Vulkan as a backend, or Direct3D as a backend, depending on if you're on Linux, Mac, and Microsoft in this case, and it'll just take care of that abstraction for you. The API itself does take some more setting up. I've included an example in today's GitHub repo. But the cool thing is, again, it's less lines of code, it works, and it'll teach you the same way that these quote-unquote modern APIs are doing things. Okay, so what do I mean by that? Okay, so the GPU API. There's really three big ideas in modern graphics. I would say modern graphics APIs. The first two have always sort of been around the last, 20 plus years. You've got shaders and buffers. Okay, so shaders, these tiny little programs that execute on a graphics card, and buffers are just chunks of memory. Okay, and I upload chunks of memory to the GPU just like we did with our texture. But the third idea is, again, sort of existed, but now it's very explicit in these new APIs, something called a command buffer or render pass. You'll see it. Right? I want to draw something. So that's me saying explicitly, these are all the things that I want to present to my render. Okay, just like we were doing before. We were doing this a little bit haphazardly, or just as we felt like. We said, okay, SDL render or texture, and then we do that a few times if we want a bunch of textures, and then present it, okay? But a render pass is more specific. It's saying, here's all the state I need, here's all the objects I'm going to draw, all the memory that I need, and I have it in this nice container, and that's what I want to ship off to the GPU. That's what this API uses. So, again, the big ideas. Shaders are going to be tiny programs that tell me how do I fill in the pixels or transform the actual rectangle that I'm moving around, the actual quad. The SDL GPU, again, since API, since it's using these modern platforms, Vulkan, Metal, and Direct3D, the shader is actually pre-compiled to a format called SPIR-V, which is a you can think of it like a executable or an intermediate representation for code for the GPU. So you can use, if you're familiar with GLSL or HLSL or really anything, slang, there's a bunch of these different shading languages to write your shader code in. So again, that's big idea number one. Buffers, again, now it's not going to be, hey, just draw this thing. It's, I need to actually create the buffer, the 4 vertices, say how they're connected, the edges of those corners of each quad that I'm drawing, and pass those to the GPU, okay? I only really need one, so it's not a monumental task. but then, how you want to transform it and so on, you have to communicate that. And then again, the third idea is, a command buffer or set of instructions or in state that you want to transfer to the GPU, okay? And this is how most of these modern graphics APIs are working. It's so you know exactly, just again, these are all old ideas, like in our event loop where I've got this nice queue of events that are going to happen. I have a nice queue of commands that can be processed, so my graphics card knows exactly what's going on. I sort of have these ready here. So again, I'm going to run the, not super exciting, but it's going to give you a good, if you are excited about this stuff, a good jumping off point here to explore here, GPU example. And there's a bunch of these, just ignore my notes there. Here, let's actually, let's just compile and run it here, and then I'll show you. We'll get our blank screen, and I'll show you the exciting thing about the blank screen in a moment here. Okay, just get a moment. There it is. Okay, here it is. But what's really exciting, okay, I've got a blank window, so we're back to square one because I used the super explicit API that sets up all the background and stuff. But the exciting thing about it is if you notice towards the bottom left corner is I am now using Vulkan. And this example is like 100 lines of code. If you've written a Vulkan example before, it's like 1,000. Yeah, people are laughing. So it's like easily over 1,000 lines of code. It's boilerplate you have to do once. So it's not like, once you get it done and build your abstraction on top of it, right? No big deal. But I think this is really nice. And again, it runs everywhere. Now, do you get all the stuff that Vulkan or these other APIs have? The answer is no, or maybe not yet, right? You have vertex shader, fragment shader, and compute shader. Now, again, excitingly though, those are the 3 things that also match what's on SDL's or I should just say web GPU. So again, if you want to target the web, there's an SDL branch working on web GPU too. So anyways, that's the exciting, I came to this talk, you said, I'm going to see a blue screen and maybe be excited about it. But that was something very cool. And you'll have the code to create your own blue screen now. All right. So, what can we learn from this? Because part of this is, as I'm doing this investigation and looking at these libraries here, is to ask a question as part of the abstract too of like, okay, we've got this great library, but what did we learn? And should we just have this in C++? Because C++ is still kind of the dominant programming language for games, let's say at least at the AAA scale. So, do we need something like this in C++, right? Do we need import graphics or include graphics? And there's been a lot of proposals for this. And maybe it is worth looking at some of these libraries like SDL and seeing what is the common functionality. Like, could I just have, like in C, there is like a non-standard or depending on the operation, like a graphics.h, basically, that you can include and just put pixels. And that's, I'll be curious to hear your thoughts, because there have been papers, at least from 2013 to 2020, you don't have to read these, but these are all the ones I could find on different graphics proposals for C++. I think there's a lot of questions about how to get vendors to agree, graphics is also a hyper fast evolving field. So, the way things we do in modern APIs is different than other APIs. But could we pick out some subset of it, or have something like SDL, or maybe we just use SDL and that's it, right? I think that's sort of an interesting thing here. Maybe we need adapters or something, in the library or something, but. But there is, some examples of this. Like, I think of stood thread as sort of an example of a success story of there's a lot of different ways to do things. Threads maybe work differently on some platforms or how they're emulated. So maybe we need something. And all I'm asking for is I would love if I could just put a pixel, take me back to my basic programming days. How exciting that was. Yeah, if you just give me a pixel that I can place, at least from an educator's perspective or somebody just trying to get into C++, then I can write my own line drawing routine and stuff. So let's maybe try to figure out a way to do that. Even if it's just software based, that could be very fun or useful. So those are some of my thoughts, just to seed conversation as after this talk or as you see me. Summarizing here, SDL's got a lot of great resources on the wiki here. So, here are some examples you can look at how I kind of go through the resources by API. Just a little example there. But hopefully you got a little bit of an introduction to SDL3. I think if you're using SDL2, it's going to be around. The developers are planning on supporting it for a while, but SDL3 is really exciting and adds a lot of a more consistent API, a lot more features, and a lot more focus on the future of how we render graphics, how we can target the web and other platforms. So I think it's worth taking a look at whether you're a beginner or pro in graphics. All right, so with that, I'm happy to take some questions. Hopefully you enjoyed. Thank you. Yeah, Tom.
Thank you. Hi, Mike. Thanks. I agree we need to have something to draw pixels as an educator. I don't care how crappy it is, because you can't make young people enthusiastic with Stutzy outs or even with formatted printing. But I have a more practical question. In the first year, we use our own little engine we write to address this problem, and it's based on SDL2. Is SDL3 ready? Fully released to do the switch? We don't want to. Is it done?
Yeah, my understanding is so the version that's out now, 3.2, is ABI stable, meaning they're not going to change stuff. They'll add stuff and do bug fixes. Valve, for instance, has already shipped stuff using SDL3. So I'm migrating all of my teaching materials to SDL3. In part, so I can start looking at teaching graphics and seeing if the SDL GPU stuff's a nice transition, even if it's like for a few weeks before we get into Vulkan in the future. I think it seems friendly. Yeah.
So, great talk. This is actually the first time I even heard of SDL3. I didn't know there was a 3, so this is awesome. I am just wondering what your opinion on the state of graphics APIs are these days. Maybe that's too big of a question, but because to me it seems like stuff was a little bit more cross-platform previously with OpenGL, and now that stuff is being deprecated, it's now less so. I just want to know your opinion on that.
Yeah, kind of matching. I think, so Apple, as far as I know, supports up to OpenGL 4.1, and then it's kind of stopped before we got into, they have Metal. There is Vulkan, but you have to go through sort of Molten VK, which is a translation layer. So, for the folks working on like game engines or backends with graphic systems, I don't, what's the right word? It's a difficult task to have this sort of fragmentation, I think. I think we're converging on the ideas of like these things like render passes and, how compute APIs and adding more shaders, all sorts of new shaders, like ray tracing shaders, all this cool stuff. But I think it's hard to be an expert now that there's really 3 or 4 APIs. Like OpenGL is still going to be around for a while, at least for the web. Then we're going to see Web GPU, and then I guess there's Vulkan, Metal, Direct3D 11 and 12. So it's we need to sort of converge somewhere. I would love if there's more convergence. As somebody who's kind of sticking to OpenGL 4 in my teaching because it's modern enough, but it's like people want Vulkan engineers out of school. They don't want OpenGL programmers anymore. At least that's not what I'm seeing. So it's a really tough time, tough transition period, I think, for graphics. But the tech is getting better, and we're seeing it in the results of games, I think, that are becoming, at least as a metric, more beautiful and interesting. But they are hard to program, or at least hard. The initial learning curve is hard. Yeah.
I'm pretty new to this, and I've joined a new team where we're rendering things on Raspberry Pis using X11. So where does SDL fit into Linux and X11? Is it on top of it? Is it parallel to it? Is it below it if you wanted? Where does it, what would I be able to go and say, maybe we should look at this because it's going to be lower resource, or is it actually going to be more because it's on top of it?
Yeah, so SDL, let's see, I can kind of show. I think I had Wayland in the image here somewhere, the image I borrowed. But what SDL is doing is it's going to provide the abstraction layer of, okay, when I call that create window function, it's either going to be like a Wayland window, or in your case, an X11 window. And then it'll pass to me the sort of handle that says, okay, give me the OpenGL context, or create that object here that can talk to the window. So, in my mind, it's working hand in hand. It's sitting right on top of it, where the SDL create window function basically has a bunch of if-defs for, okay, create an X11 window or whatever, and give me the hardware accelerated one. So I think this could be it's probably worth investigating. I don't know your specific use case.
Does it have a mode where you could actually skip X11 and do something even lower on a Raspberry Pi?
Oh, does it have a mode for skipping X11 for Raspberry Pi? I don't know, because I haven't done too much stuff. I don't know. I think I can get handles to any sort of window if I have one, and then sort of set the context. So as long as you can get like whatever that windowed object is, you can probably push pixels into it. But I'll have to think about like if you can create the OpenGL context, you could use this API to push the data there. Yeah. So it's probably worth taking a look at. Yeah.
Since you were talking about education and how to get people into it, have you looked at Raylib?
Raylib, yeah, I have. I haven't used it too much. I think that's another excellent example. All the examples are on the web. It provides a lot of stuff for just getting up and running, like 3D object loaders, some of the stuff that SDL doesn't have. I think Raylib's awesome.
Yeah, I guess the issue is it's OpenGL, but I think newcomers will just scream if they saw Vulkan.
Yeah. Yeah, I think just for getting folks, again, this is one of the things where it's like, I feel lucky when I got started, and maybe other folks like who learned assembly when they were programming were like, oh, I'm glad I learned that. So yeah, Raylib's an awesome, I should put that on the list as well.
I think maybe we'll take one last question and then we'll break for lunch.
Okay, so I'll get the second one, yay. One of the things we're struggling with at our university with SDL, we have this whole discussion, and it's based also on what Kate says. We should teach C++ and not C. And then for our entire graphical context, we're using a C library, which is not ideal. So there are voices, and we're looking into it now to do you mentioned it as well, FSML? Yeah, because that's C++ based. Do you have any thoughts on that?
That's a tough one. I've tried to, because in my university we don't even have a good path for C++, so sometimes I use D, and that's nice because it talks to C, all the graphics APIs, right? Have some C interface. What can I say about that? It's probably worth, it's worth looking at it. I would try to find somebody else who's doing SFML. And I used to do a little bit of SFML when I was teaching C++ as well, and had good results. I do have a ACCU talk a few years back on how I teach programming one pixel at a time, and I was using SFML for that. I'm just trying to think in the context of gaming stuff where they're going to live in C APIs. And it is kind of useful to think about that. Like I mentioned, the resource management stuff and saying, hey, if this is a C API, you kind of want to be explicit, and here's why we maybe build the abstractions on top of it and have these manager classes. But yeah, I don't know if that means throw away all the C++ stuff and do the semester in C. I don't have a great answer. I'm leaning towards these days of, and even going back to Scott Hansman's keynote of, let's look one layer down. I actually want my students to know more C stuff because that's what the world's still built on. And then then we can add the object-oriented stuff on top of it and get into the SDL. So I go back and forth. But I'm also the big proponent of Kate's Stop Teaching C talk too. So, yeah. But yeah, thank you. Happy to talk more.